So now my clipboard contains up to 100 million trials of 20 part failure distributions, right?
Mm-hmm.
And I'm going to head back now to the problem here, the problem at hand. Okay, boss, how long do you want this plane to fly? And the boss says, well, I see that the minimum mean time to failure is 383 hours. I want it to fly 383 hours. Great, I'll tell you your chances. Okay, so here I put in a greater or equal to sign. I put in 383. And now I'll tell you the chance that that happens. So I go to chance calc. So this is this little add-in that is going to create a chance-informed model. What's important is once I build a model, you don't need the add-in anymore. It's just native Excel. So there are two buttons here. The first button is SIP input, get the SIP. The second button is the chance of whatever button. Those are really the only two buttons you need. So I'm going to get the SIP, and the data is on the clipboard. So I'm going to click that thing. Oh, there are all the parts. All right. So what I need to do is I'm only going to grab the first 4 parts. And I'm going to put little graphs of those uncertainties there. So here goes. Now I grab part 1 through part 4, and I click OK. Oh my goodness. What's happened? Well, I'm looking at trial 1 of thousands of trials. Here's trial 2, trial 3, trial 4. And at this stage, I'm going to calculate the chance that we're grounded in a time that is greater than 383 hours. So I go down here. I click on the chance of whatever button. The chance that the time to being grounded is greater than or equal to 383. So, I don't know, folks. What do you think that chance is? Time to put your money on the table.
Yeah, exactly.
Okay, here goes. 4%! Oh my God! Oh no! Wow! Wait a minute. Are you sure you want to keep using averages for this? Now look, these little graphs over here are telling us what the relative likelihood is of different durations. I mean, these are probability distributions. Let's face it. Okay, and another question you might ask is, well, what would happen on average if we did this over and over? And I'm just going to use the average button here. So what's the average of when we would expect to be grounded? And remember, if you used average inputs, which is equivalent to saying, oh yeah, a die always comes up 3.5, or the river is always 3 feet deep. If you use those averages, you say, well, we'll be done. We'll fly for about 383 hours, right? Let's see what happens on average. Oh no!
Wow.
158 hours. That's not even half of this.
Yeah.
So, I mean, the flaw of averages in this case, it's just ludicrous to use.
So the manager that responded to the boss 383 earlier just straight up lied. Deceived.
Well, that might not have been intentional lying. They might have had no idea, but I mean, it's not even close. And by the way, the boss may say here, look, well, we better not promise the client 383 hours. Oh, you know what? Let's give ourselves some wiggle room.
Yeah.
300 hours. That'll probably work. Right. 10% chance of that. No. So this goes back to your notion of there are trade-offs. For one thing, I want to please the client. The client wants lots of hours. Yeah. But what's the chance? But now I am lying if I've looked at this model and I say 300. I mean, so you can see all these trade-offs taking place. So that really is sort of the conclusion of this whole process. We're now making chance-informed decisions where we can put in different numbers of hours, find the chance that we can fly that many hours. We get the average over here. We get true statistical information without triggering post-traumatic statistics disorder. But only if you have good data scientists to do this, if you have an open data standard to communicate it to people. And we didn't have to do this in Excel. The SIPMath standard would work in Python, in R, on an abacus, if you were willing to take the time.
Yeah. And I think today you covered just some very fundamental points, and I'll just very quickly recap that. The difference between deterministic and stochastic decisions or chance-informed decisions is staggering. And you know, this is an illustrative hypothetical example, but in my real life, it was a matter of like life and death, you know, billions of dollars difference. As soon as you add volatility to your decisions, they sometimes change so dramatically that you just go, wow, this is just amazing.
Absolutely. And look, the science isn't new. The science goes back to Jacob Bernoulli in 1676 or some crazy. The transformation came really with computers, and so in 1947 they developed Monte-Carlo simulation at the Manhattan Atomic Bomb Project, you know. Yeah. And electricity has been around a long time. Benjamin Franklin was studying electricity with his kite. Yeah, it took a long time between Benjamin Franklin and 60 cycle AC current, which really, you know, came in the 1890s, right? Mm-hmm. And so this has not been a revolution, it's an evolution, but suddenly everyone started using light bulbs. And now everybody should be making chance-informed decisions instead of average-informed decisions.